Hi.
Hello.
I think that you can start and share your screen.
Okay, great. Hi, everyone. Let me just share my screen and we'll just get right into it. Let's see. All right. How's that? Is everybody able to see my screen?
Yeah, we can see your screen.
Okay, perfect. So thank you for this opportunity to allow me to speak here at this event. I'll give a brief about myself. I come from a technology, business, banking, and finance background. I worked for large tech companies like Oracle and Finestra. I worked in banks. My area of expertise is running business applications and finance transformation programs for financial institutions, um, pri- primarily in the area of financial applications and data analysis and analytics. So I'm a kind of a hobbyist Python AI person which likes to think around things. And so today we'll be talking about how we can build prototypes in Python using the most recent generative AI technologies that are out there, which enables us to accelerate our implementation of such applications. So even though I'll be talking more on a financial use case, we'll be covering other generalized topics also. So great. Let me just move my screen. So is my screen moving? Is everybody able to see my screen?
Yeah, we can see your screen.
Perfect.
It's great.
Perfect. Great. So while we're in this discussion, there's my LinkedIn details mentioned here. You can always drop me a note on LinkedIn, and I'll be happy to take any questions over there. Or if anybody wants to take connect with me, I'll be happy to do that. And of course, later on in this session, I'll be able to take questions from you guys. So now, what we are in the era of AI transformation or AI adoption, AI adaptation, whatever you want to call it, it's here to stay. However, we have been exposed to AI technologies all throughout the last 2 or 3 decades. Just recently, due to these natural language processing capabilities of LLMs that have now made things available to general public, which enables us to directly interact with AI technologies. Earlier, we were interacting them in the behind-the-scenes model where we were exposed to the machine learning algorithms of recommendation engines, pricing engines, but mainly at a very abstraction layer. Now we're directly interacting with AI at a very direct level. So what is necessary for us to build AI generated applications? First and foremost is there's no right tool or wrong tool out there. The most important tool out there is us as human beings. We need to have certain skill sets in our arsenal to be able to do any kind of a initiative, any kind of a project, any kind of a software application development that we want to do. So there are certain foundational skills that one needs to have. Obviously, you need to have data specific skills. You need to be able to be creative and in problem solving and coming up with ideas. More importantly, we need to understand the legal, ethical ramifications of what we try to do, and of course, adapt and learn from that. And more importantly, we should be in a position to gain knowledge and share knowledge at the same time. And more importantly, ability to collaborate and communicate with our peers and other stakeholders that we usually work with. So when we bring something to life, it's not in a silo. We have to collaborate with other individuals. So these skills are essential when it comes to doing anything in our profession, and more importantly, when we aim to build technologies which are now accelerated using generative AI capabilities. So I will be talking about how this evolution has occurred. We started off in the early 1950s and 70s in adopting software into our mainstream businesses. Like mainstream businesses, meaning, if you remember, there were mainframe computers, there was assembly language, Fortran and COBOL. A lot of automation started happening during that era. And in the 1980s, a more higher level of abstraction of software programs that were introduced, which allowed us to do object-oriented programming. And of course, in the 1990s, there was this huge internet revolution that happened, and we know how things went from there. Why I'm trying to highlight here is what has happened is a journey that we've all gone through and being where we are today and adopting and adapting to AI transformation that we are currently in. Now, as part of the part two of this journey, in the early 2000s, there was a huge shift towards online digitization, cloud transformation, cloud lift and shift. And then that led to the capabilities of very high compute that made available, and of course, the data that was now made available to us to do machine learning on it. So from the mid 2000s to the early 2022s up to the pandemic era, a lot of machine learning was happening, but this was behind the scenes. We as end users were not getting engaged with it in a direct sense. From 2020 period onward, there was this like a proliferation of LLM-based generated AI models that we came across, and we all know how that has turned out. We now use this LLM-based generative models to do many things in our lives. Lawyers are using it to analyze cases. Doctors are using it to do research on any of these medical journals and publications. And also the data scientists and software developers are now using these tools to come up with new ways of prototyping and building applications. Okay, so what I'm going to be talking today is there's a component of time series analysis that we call where the data is cataloged and logged in a specific timestamp. Now, this time series analysis is prevalent to many industries and many sectors. So in this talk today, we'll be covering mainly around algorithmic trading and risk management strategies. However, it is applicable to in the industry of healthcare, like patient monitoring, epidemiology, in the facilities, process, and manufacturing industry. It's applicable there when it comes to maintenance. It's applicable towards supply chain industries for demand forecasting and inventory management. It's applicable for energy, power generation, where you have to manage load based on certain time of the day. And of course, there's also a more advanced way of doing power pricing, which is all time series analysis. We already experience weather driven events. So we know today, tomorrow, day after, 1 week from now, this weather prediction and weather forecasting is all driven by this time series analysis based on timestamps. And of course, then we are, some of you may be doing network engineering, and you understand there are timestamps for each of those packets. So it's all time series data that has come in, which allows us to do certain fraud detection, fraud behavior on that. And there's economic forecasting, right? So we know every month, every quarter, every year, there's certain financial indicators released by the central banks, by the businesses, by other sectors, which gives us the health of the economy. And based on the past historical trend and future forecasting, we're able to determine how the economies are going to be behaving going forward. So this is all time series analysis. Now, what we do today in this talk is mainly of giving an indication that where we are headed towards using this AI adoption, right? So we know AI is now being used in our health care, AI is being used on our financial services, AI is being used in by the governments, and this is going to positively impact our GDP, which is we anticipate in the next 4 to 5 years, around 26% of our global GDP will be having a positive contribution because of AI. So now, what I've done is to simulate or build a prototype application, I've gone ahead and trained a generative AI model using certain business and management and technology practices for software development. So we all, some of us may be familiar that there are certain methodologies and frameworks being used in software development lifecycle, and a similar concept exists in data analysis and data analytics. So I've mapped CRISP data management method on top of the lean development method to come up with a approach that allows me to train the model in a way that it will give me disciplined results and disciplined outputs. So it's important that you tweak and tailor your models, AI, LLM models, to generate outputs that you desire, right? So since I come from a technology background, I come from a program management background, I come from a data analysis background, it was very much important to not reinvent the wheel. So what worked in the industry, I took those methods, I took those frameworks, I took those architectures, and I trained the model based on those proven real world best practices, so that when it gives me the output, it is designed in such a way that it works. So next one is I also trained the AI model to recognize in the real world how teams are structured, right? So we know these generative LLM models are neural network based. So it's there to mimic or simulate how human neurons behave. And similarly, in real organic organizations, the structure of the team, some people are specialists in being DevOps, some are specialists in quality assurance, some are specialists in data analysis, some are specialists in doing software development, software engineering, data architecture, all of this. So I trained the model recognizing all the different skill sets and expertise that usually exist in a team structure to be able to come up with the output that is real world centric. Okay. So coming back to the same point I was mentioning, again, it's a process that one has to understand and how things work. So I trained the model adapting to the real world processes which are applicable towards building financial applications and prototyping applications. So there was a business planning. We usually sit down with end customers or end users to plan and understand their requirements. Then we start preparing our data, or we start and then we go and model what is going to be expected from this prototype or from this data set. And then, of course, we do an evaluation and we go into loops and recursively figure out how we can optimize and perform. And eventually, once we are happy, we deploy this into production. So similar process was used to train the model to be able to recognize that these are the stages or steps it should consider when it comes to developing a prototype application that I will be requesting it. All right. More importantly, it is also relevant to give a structure of what the architecture should look like. So as I'm training it from a high level down to a low level, I need to also give the architecture of the application that I'm seeking. This comes from the real world experience of how things are structured and how classes or object-oriented programming was done in the past. Now, of course, there's a evolution of agent-based programming, but I've stuck to a simple example of object-oriented programming. So what you see is the architecture, which is going to get translated into classes and will generate code based on that. So give you a brief example. So data ingestion is where the data is going to get collected, data is going to get pre-processed, and then there's a strategy implementation for this algorithmic trading that we are going to be implementing using AI and Python. There will be a testing or back testing engine. There will be certain risk management and trade execution rules that are going to be embedded. And of course, we go through the optimization phase, and eventually we deploy it and we do a constant monitoring. So we are familiar, there's a concept of ML ops or LLM ops. So eventually it goes into production. So I've been very cognizant here. I've not included the CI/CD DevOps here. I remember this is just a prototype. So once you build production grade applications, even the CI/CD and DevOps also come into play, and then this becomes repetitive and recursive. All right. Now, keep going a bit more deeper. Some of you may be coming from a software engineering background, so we know there are design patterns out there, right? So why reinvent the wheel when we know things work? So I even went to a level where the modules and the classes that we're building, I gave suggestions to the model to recognize such design patterns and consider these functionalities. So when the functions are being developed or certain rules are being developed, it recognizes these architecture requirements that I've given to it, and it will be able to generate code based on that. All right. So how did I do it? So keeping it very simple, I used ChatGPT 4.0's LLM capabilities. I built a custom GPT using GPT 4.0 called Quant. I trained it using all the inputs that I had provided through prompt engineering and certain data sets and certain collaterals and artifacts that I uploaded in it. And through prompts and through interactions, and after a couple of days of training, it was able to perform what I was expecting it. So what was I expecting? So if you can see, I wanted it to be able to research trading algorithms and strategies that works best. Also, even though I have initially trained it on a delivery methodology, I asked it to further iterate and enhance and improve rather than sticking to what is set in stone, but have an evolutionary continuous improvement process also in place. And of course, whenever I give certain requirements, it goes into a requirements analysis mode, similar to the team structure that we had put together, the teams talk to each other and analyzes and then comes up with a solution architecture and a system design, and eventually this leads to a template boiler code generation, which then goes into GitHub Copilot using Visual Studio Code. So in Visual Studio Code, GitHub Copilot, I'm able to refactor the code. I will be debugging and testing that code, and more importantly, because this is an algorithmic trading strategy built on time series data analysis, the parameters that are being recommended by this algorithm would have to be constantly tuned and optimized to get to a level which fulfills the business purpose that we had initially planned out as part of a business plan. All right. So also, it's important to recognize, and this is what I also used to train the GPT-4o LLM, is the data I provide. I provided certain data sets. I'll show you what I mean by that. I provided certain prompts. So this custom GPT called Quant Lab was able to generate boiler code based on the inputs that I had provided to it using historical data and certain research documents. I'll show that to you in the subsequent slides. And then this boiler code went into Visual Studio Code GitHub Copilot, where I was able to refactor the code, test the code, and I was able to generate process data based on certain market data that it pulled in from the broker and other data feeds that it was able to collect using the data collection class that we had defined in our architecture. Then this goes back into this custom GPT called the Quant Lab for doing further insights and data exploration and analysis to determine the outcome and output that we're expecting out of it, right? So again, this is like a human and an AI interaction happening. So I'm the human in the loop, and my AI is this Quant Lab, custom GPT, and GitHub, where I'm interacting and making things happen. And once I'm happy, I'm satisfied, then I can baseline the code and I can move on from there. So again, I'm emphasizing here, it's important to give any AI tool the context and the right data set and the right information to give the right output, garbage in, garbage out. So if I'm able to specify exactly what I'm looking for, then it will give me the right output that I'm expecting. So hence, I'm being very particular about what system architecture I'm looking for. Otherwise, we all are familiar that there's a concept called hallucination. The Gen AI can start hallucinating, coming up with stuff which is not relevant, and eventually this may corrupt the whole software application, and we don't want that. And we already are struggling and fixing the bugs. The last thing we want is AI to come up with more hallucination and data and software issues that we want to go diagnose. All right. So one of the prerequisites for training this Quant Lab Custom GPT was providing it some context. So I'll show you what those contexts are. And of course, I provided it with a starter code from my previous projects, which I know works and they are like bug free, so that at least the algorithm that is being built out is based on certain personal preferences of the code that I prefer how it should look. So if you notice, I've been very specific in telling this AI algorithm or AI Gen AI capability called Quant Lab do what I expect it to do. And now I'll show you how it's done. So let's do a walkthrough of the Quant Lab and the Visual Studio Code. I might be doing some switching here, just bear with me. Okay. Are you able to see my screen?
Yep, we can
Perfect.
see
Great.
screen.
So this is ChatGPT 4o Quant Lab, which is a custom GPT that I trained. And I will give you a brief of how it was trained. But just to give you an idea, I was loading all the starter code that I was talking about. These are Python scripts, and also a PDF document which contains the trading strategy that it needs to read through and then come up with a trading model, right? Or a strategic model that is required, or the data model that is required for this application to behave in. So there was prompts, there were outputs, there were code that was generated, and you can see this is, and there were some visualizations that were done, some exploratory data analysis that was done using the Quant Lab GPT-4o trained this generative AI capability. So just by the way, I will be sharing. You can use this Quant Lab feature using, if you have a GPT-4o subscription, you can easily access this and you can use it for free. This is for everybody to use. So it was able to interact with me through chain of thought. If you're familiar with this concept of prompt engineering called chain of thought, so using chain of thought, I was able to give it prompt, it gave me an output, then I gave it a prompt, and I noticed things. And what I did was some of this code, then I brought it into Visual Studio Code. I refactored it, I executed it, and then eventually this was a kind of a recursive iterative exercise between GPT-4o and GitHub Copilot using Visual Studio Code. So I'll show it to you also over there. So give you an idea, a lot of prompts, a lot of code, but point in notes to be noticed here. This is something not for the novice. If you know what you're doing, you know what output you're seeking, GPT-4o or any kind of Gen AI tool is just a tool to enable you, to assist you, to support you. It will not do stuff for you. It is not smart enough at this stage where we are today to be able to comprehend what you're looking for. You have to be very specific what you're asking, and it will give you specific outputs. And you also have to recognize that the outputs that you're giving or that you're receiving is meeting your need. Sometimes it's hallucinating. It's sometimes incorrectly giving me the source code or the output that I'm expecting, and I need to go and correct it also. So this exercise went on for a couple of days for a lot of training, and lucky for you, I've already trained this, so you can go and use this. So eventually I came up with a certain code, which is a template code, which I was happy with, and now I'll show it to you in Visual Studio Code, right? So I ended up creating a Python Jupyter notebook where I copy pasted some of the code and I started refactoring and playing around with it. So by the way, if this is Visual Studio Code and this is the IDE, and you can use this chat feature over there. If you have a GitHub Copilot subscription, you can then start interacting over there to do the code refactoring. So again, I provided an initial starter prompt, then this composition using chain of thought started happening with the GPT-4o data, and coupled with this GitHub Copilot data, and eventually I came up with a output of a code which I was reasonably satisfied, right? So I can consider this as a baseline prototype version that we can now use for any other exercise. So similar framework can be applied to any kind of a data analysis project that you're doing, where you have a certain data set, you have a certain data strategy, you have capabilities offered by GPT-4o, which you can then custom train using custom GPTs that you have, and eventually use these both tools in conjunction with each other to come up with a prototype application, which you can either use it for your own personal need, or if you want to commercialize it, of course, there are certain steps that needs to be added on top of it. So this is just a brief of what I wanted to cover here. And now, so okay, what's next from here? Data analysis and analytics has been there forever. It started off with mathematicians, statisticians, and the advent of technology and automation and cloud technologies. Now data and analytics has been the mainstream. AI was also there, but now thanks to the natural language processing capability of these LLM models, us human beings are able to accelerate our creative thoughts and build things and applications and even ideas where we can prototype very fast and very iteratively in a much faster pace, which was not prevalent in the past. Now, where are we heading? Where are we going from here? I know we all are talking about artificial general intelligence that is coming in. I think it's going to take time, another 3 to 4 years. But the key point to be made here is we as human beings have always evolved, has always adapted, has always accepted this technology because we are the ones who create this technology. So it's important that we keep up with it and then upskill ourselves, embed these new tools and technologies into our daily lives, into our profession, and leverage them to our benefit. So thank you so much. I'll be able to happy to take any questions if there are any.
Thank you, Arsalan. Is there any question for our speaker? I think there's no question. So, okay, thank you for your presentation. It was really